In this chapter, we are going to implement the infrastructure layer, which is one of the outer layers of the clean architecture. It's responsible for any external facing concerns like databases, message brokers, identity providers, storage providers, and so on. What we are going to add to the infrastructure layer is EF Core. This includes the database context, entity configurations, and repositories. We're also going to implement optimistic concurrency support and publishing of domain events. In some implementations, you're going to see the infrastructure project being split into multiple projects. For example, you could have one project related to databases, another project related to message brokers, one more project related to identity and authentication. So depending on your needs, you have a lot of flexibility here. We are going to be placing everything inside of one project, and when we are done with the infrastructure project, our solution is going to be nearly complete. Let's start this section by adding a class library that is going to contain our infrastructure project. I'm going to call it Bookify Infrastructure, and it's going to be a .NET 7 class library. I'm going to delete the default class that is added to a new project, and let's see what we need to implement the infrastructure project. I'll start by adding references to the application project, and by extension, I'm also going to be referencing the domain project. I'm going to add a new class that is going to be responsible for dependency injection for our infrastructure project, and we're going to make it a static class and define a new static method inside. This is going to be our extension method on the iService collection interface, and we're going to call it add infrastructure. I'm going to add this iService collection and give it a name of services, and I'm also going to add one more argument, which is going to be the iConfiguration instance. I'm going to need this interface to be able to wrap my connection string from the application settings so that I can connect to my database. This interface isn't available out of the box, so I'll have to add a NuGet package. The one I'm looking for is Microsoft Extensions Configurations Abstractions, so let's go ahead and install that one. So now we should have access to the iConfiguration interface, and let's see what we're going to add in our add infrastructure method. We can start by returning the services instance, and let's go ahead and define our first service. I'm going to add a new folder inside of the infrastructure project, which I will call clock. Inside of this folder, I'm going to add a new class, which is going to be my datetime provider. I'm going to make this class internal and sealed, and it's going to be implementing my iDatetime provider interface from the application layer. Now the implementation by default is just going to return datetime UTC now, and we have a functioning datetime provider. Let's register this service in our dependency injection class. I'm going to say services, and we can register it as a singleton or a transient object. Let's, for example, go with a transient, and I'm going to say iDatetime provider, and the implementation is the datetime provider class from the infrastructure project. The next class I'm going to add is going to be my email service, so I'll add a respective folder. I'm just following the naming convention that we have in the application project, and the class inside is going to be called email service. I'm going to make it internal and sealed, and it's going to implement the iEmail service interface from the application project. Now here, I don't want to be doing anything related to an actual email service, so I'm just going to return a task completed task to simulate that this method completed successfully. We also need to register it with dependency injection, so let's go ahead and add it as a transient service. I'm going to say iEmail service as the interface and email service as the implementation. Now let's introduce Entity Framework Core to the infrastructure project. I'm going to start by adding the EF Core NuGet package. So let me search for Entity Framework Core. I'm going to install the provider for PostgreSQL because this is the database that I'm going to be using for this project. Let's install that one. With the EF Core libraries installed, let's go ahead and define our database context. I'm going to define the database context at the root of the infrastructure project, and I'm going to call it application DB context. Going to be a sealed class. It's going to inherit from the DB context base class, which is available in the Entity Framework Core namespace, and it's also going to implement the iUnit of Work interface that was defined in the domain layer. The iUnit of Work interface exposes a single method which is called SaveChangesAsync, and our database context already implements this method, which you can see here because the interface isn't complaining that we are missing a method in our class. The only thing I'll do right now is define a constructor which is going to accept the DB context options class and is going to pass it to the base class constructor accepting this type. So this is all that we need in our database context for the time being. Let's see how to register EF Core with dependency injection. I'm going to start by using the iConfiguration instance to get the value of the connection string from our application settings. This is the connection string that EF Core is going to use to connect to our PostgreSQL database instance. To register EF Core, we need to call the addDBContext method, which is exposed by Entity Framework Core. We specify our database context as the generic argument, and then on the database context options builder, we need to call the specific provider that we are using as our database. In our case, this is going to be Postgres, so we have to call the useMPGSQL method and give it the connection string so that it can connect to our database. EF Core by convention is going to use title case for the names of the tables and columns in your database model. Postgres, on the other hand, prefers snake case. So I'm going to add a small NuGet package to my infrastructure project, which is called EF Core naming conventions. Let's go ahead and install it. And what this allows us to do is to say, after we call useMPGSQL, we can say use snake case naming convention. This is going to align my table and column names with the snake case naming convention, which is what Postgres is using, and also the SQL that we added in the application project was referencing this naming convention for the columns and tables. With EF Core properly wired up with dependency injection, let's see how we're going to add our domain entities to the database context. Now we need to connect our domain entities with EF Core, and I'll remind you that we implemented them in a persistent, ignorant way. We designed a rich domain model, and how we're going to map this to the database is by using EF Core's Fluent configurations. I'm going to start by adding the configurations folder inside of the infrastructure project, and let's create our first configuration class, which is going to be the apartment configuration. I'll make this class internal and sealed, and it's going to implement the iEntity type configuration interface from EF Core, and we also need to specify our domain entity. So I'm going to say this is the iEntity type configuration for the apartment, and we implement the configure method. Inside of the configure method, we're going to add several things, so let's examine what we have. This is EF Core's Fluent configuration approach using the Entity Type Builder class. The first call here is going to map the apartment entity in our domain model to the apartments table in the database. Then we are defining a primary key, which is the ID of the apartment. We are mapping our address value object, which I'll remind you is a complex object with a few properties using an owned entity. How this works with EF Core is the value object is going to be mapped into a set of columns in the same table as the owning entity. So in this case, the address columns are going to be in the apartments table. If this is a collection, you have support for calling owns many and mapping a collection of value objects, but in that case, the owned collection is going to be mapped into a separate table. For simple value objects like the name and description, we can set the maximum length to 200 and 2000 respectively, and we're going to define a simple conversion from the value object to the primitive type in the database and from the primitive type back into the value object. For mapping the price and the cleaning fee, which are money value objects, we are also using the owned entity approach with the added step of defining a conversion for the currency, which contains a code inside. So we're only mapping the currency code to the database. I'm going to add the user configuration, And if we take a look at it, you're going to see that most of the things are pretty similar. We're mapping to the users table in the database, and I want to highlight this line here, where we are defining an index on the email property, or rather the email column in the database, and we are saying that this is a unique index. This is going to give us a database guaranteed constraint that the email is going to be unique across the users table, which is an important quality that we want from the database. I'm also going to add the review and the booking configurations, and they're all going to be pretty similar to what we already had. In the booking configuration, we also have configuring of relationships. I'm defining a relationship from our booking entity to the apartment by saying has one apartment. An apartment could have many bookings, which is why we have a call to with many, and we are defining which property on the booking entity is our foreign key. The same approach for the user, which could have more than one booking, and the foreign key is the user identifier. We have our entity configurations, but how are we going to apply them? Let's go to the database context, and here we are going to override the onModelCreating method. Inside of this method, I'm going to say model builder, apply configurations from assembly, and I'm going to specify the assembly containing my database context. When our model is being configured, it's going to scan this assembly, find our entity configurations that we added in the configurations folder, and apply them to the Entity Framework data model. Now there's no risk that you'll forget to apply your entity configuration because it's going to be applied automatically. With our domain entities configured with EF Core, let's go ahead and tackle the repositories.